It is good.
Yeah, it's good. You can continue.
Okay. So, hello, good evening from India. This is Shitanshu Sekhar, ex-student from Nalanda University, Rajgir, and currently I'm serving at Raksh Prakriti, non-governmental organization in Jamshedpur, Jharkhand. So, I will be talking today from one of my research, which is sludge-derived biochar and a solution to textile dye pollution. So, let's move ahead. So, if we talk about why this is sludge, so there are different biomass, but I have selected the sludge. So why sludge? So if we consider the background, then there's sludge, then India, then total generation based upon one of research paper of Kumar and Saha. So total generation in around 72,000 and 368 million liters per day. Then after treated is 20,236 and untreated is 52,132. So we can think of like what are the current scenario. We should be worried about this scenario, and so how these are the channelized. So if we talk about domestic or industrial wastewater, then from that wastewater, then sludge generated, then sludge is used widely used as a fertilizer from any treatment plant in India. We can see like after the sedimentation process, the sludge are recovered and then it is dried on the sludge dryer bed and then it is used as a fertilizer. It is widely used. So it causes three things. So first is generation of associated risk. So fertilizer, if we use direct the sludge to as a fertilizer, it can generate some risk. So that is it can accumulate, it can result to the accumulation of heavy metal and its magnification. So we need to go for the possible alternatives of this. And then it is I have researched for dye, textile dye. So in 1856, first time synthetic dyes were prepared from aniline. And what does it mean? Like it is nothing but hydrophilic aromatic complexes that is not really biodegradable in aqueous environment. So the complexes which are hydrophilic aromatic and which are not readily biodegradable in aqueous environment are termed as dyes. So there are around 10,000 synthetic dyes and 800 dyes are under 40,000 color index trade name. So what is color index trade name? So there are different dyes, as I said, like 10,000 synthetic dyes and 8,000 dyes are under 40,000 color index. So different names are given based on the color name, like red, methylene blue, or methyl orange. There are different. Among all places, if we talk about India, so there is a place in south called Tripur. Textile city is the city which is facing the most of the problem from the textile dye discharge. And these are the some sources of textile dyes. So different type of dyes. It can come from leather or paper or pharma industries, textile industries, food industries, cosmetic industries. Different type of dyes can be discharged from these industries. So these are the sources for the dye, textile dye pollution to different water system, soil system. And what are the impacts of dye? So we can clearly see in this picture like dye leaching to various ecosystem from the clothing, textile industries. Then if it is directly discharged to water bodies, then it alters the physiochemical properties and degradation of recreational value of floras. If we and all COD, DO, different biological properties, chemical properties, physical properties get altered. And if it is entered in the aquatic life, such as fish, then even DNA modification and mutation can be possible, some results suggest. And inculcation of all, it has the multiple health impact on human body, like it can cause allergies, respiratory problem, eye irritation, even some are carcinogenic, kidney problem, even skin irritation, and there are results for fertility problem also. So sludge impact. So sludge can be used as a soil enhancer, as we have seen, like putting the sludge, it increases the fertility, and we are getting the good production. But along with this, problem arises due to excessive use when it contains concentration of heavy metals. Let's suppose the sludge are mixed with the industrial sludge, and then it can contain the heavy metals, and which arises the different problems. So what are the other way application? Then the play come and for the biochar. So sludge biochar as an alternative to reduce the contaminant. How it can reduce? So biochar is prepared as in the previous presentation we knew, like on the by the process of pyrolysis. So it is heated at very high temperature. So what it does with the biomass, it like the mobility of the metals, heavy metals, is reduced after the heating. And this picture you can see is the biochar prepared by me during my research process from the sludge. So if we characterize like in 2-3, so it is biochar nothing but carbonized biomass. It is make conversion of the carbon into like complete carbon it is, and it is low cost absorbent also, and it has some potential in textile dye removal also, which we will see in the resultant discussion part. So what are the methodological steps? So we need to first prepare the raw biochar, and then followed by modification also, like some material we need to modify the biochar with some addition of different chemical to increase the sorption capability. So first of all, for raw biochar, sample collection, then air drying, then oven dry, and then crushing and sieving at the very minimal, like if there is column experiment procedure upcoming, then we need for ball milling also. Ball milling is nothing but crushing with the very fine size, very micro size of the biomass, and then washing and filtration, then again oven drying, and then bottling for the further processes. Same for modification. If we are doing the modification to the raw biochar, so what are the chemicals anyone is expecting to do the modification? So desired quantity of that chemical should be taken, and then with the raw biochar it should be mixed, then sonication and stirring, and then oven drying, and then stored for further experiment. In some cases, which have results in different researches also, like if we add some magnetic effect, so ferrous ferrichloride is used. So before the oven drying and further bottling up, we need to wash, because it may be possible that it leach the color. So we need to wash the surface, so the sorption capability will be high and the surface area will be high to absorb the pollutant. These are the snapshots of my processes during my research, like air drying, making of stock solution of dye, then sonication, then after pyrolysis, then the final product as a biochar, filtration with the nylon filter during the washing processes. So these are some snapshots of my processes. Then we come for resultant discussion. So what I did, I worked for 4 type of biochar. First was raw, then I have activated that, then I have some biochar for magnetic effect, and I have some for activated magnetic. So first I have studied the study of contact time. So the trends shown that after the 120 minute, it shows the straight line. So maximum absorption were achieved at the 120 minute. Before that, we need to calibrate the sample of the dye, whichever dye you are making. For example, if we we are working with the methylene blue dye, then we need to calibrate first to know the wavelength. At what wavelength it is maximum absorbed, and then these studies should go on. So a study of contact time. So we can see like in the raw and the activated magnetic, it shows similar trend like up, and then straight. And after 120 minutes, it was the maximum point. And in physics, what we call it fracture point. Then study of pH. So if dyes are many kinds, like some acidic dye, some basic dye. So we need to know the study of pH also. So at what pH the maximum removal is like getting reflected. So I have worked at 2 pH, 7.4 and 1.5. So we can see like different colors are there, raw biochar, and then activated, then magnetic, then activated magnetic. So what we can see is like the removal at 7.4 pH in comparison to 1.5 is greater. Like so what it reflects, the dye were basic, so it gave the result better at like greater pH, 7.4 pH. Then study of biochar dose. So it was very interesting for me also. So just we can see like if we can add 1 gram per liter and versus 5 gram per liter. So in this case, the removal was in 1 gram per liter. The removal train followed of some pattern at and then in between 60 minutes to 120 minutes in the first graph, we can see like it is quite similar. But what we can see, if we increase the biochar dose, in the very first 5 minutes, the activated magnetic biochar, which is the fourth type of biochar, is removed maximum percentage, around 90% of the methylene blue dye from the water. And then and other 3 biochar required more time. So what does it reflect? It reflects that increasing the biochar dose will reduce the process time and greater removal also. And then we can study the coexisting ions also, like 3 different concentration solution of NaCl, and then with the addition of known amount of biochar in them, and then study the performance on the spectrophotometer. So what does it reflect? Like with the increase in time and with the higher concentration, 50 molar mole of the NaCl, really like remove the most of the dye from the solution. So based on these researches, based on these results, what we can conclude is like sludge derived biochar has emerged an efficient adsorbent for dyes. But yes, presence of some hazardous material also suspected, which can be triggered via different characterization methods. And like AAS method, FTIR method. AAS method can be used for the presence of XRD method for the presence of heavy metals, hazardous material into the sludge or the biochar prepared from the sludge. And as I have mentioned in the earlier, like immobilizing capability it has, so it is useful adsorbent. And based on the resultant, like it removed 90 or more than 90% of the dye, one of the textile dye from the water or the aqueous solution. So we can say that the modified biochar compared to raw biochar can be used as an effective adsorbent for removal of textile dyes. So yes, but again, these were my references for my presentation and some of for my research work. So thank you. There is my contact detail, my email ID. If you can need further any information, you can contact. But yes, these like this study was the batch experiment. So I am still exploring the column, the field performance of the biochar. So on batch experiment, on lab experiment, it shows like Sludge derived biochar has the capability to remove the one of the major concern of the textile dye. Thank you.
Yeah, hi. Okay, is there any